Okay, first question. Solve d2x dt squared equals 2x 9 plus x squared. Given that x squared is given that dx dt is 9. Okay, so dx dt is 9. So what we're going to do first and foremost is we're going to have to use the chain rule. Now, this is working. No, just give me 1 second. Here we go. First one. What we're going to do is we're going to change d2x dt squared into dv dt. Now where I get this from is I basically say it's the derivative of dx dt, and then what I say there is that let v be equal to dx dt. Okay, so what we're going to get now is dv dt, which is d2x dt squared equals 2x 9 plus x squared. Now the problem here is the variable is x, yet what we're differentiating it with is dt. You're not allowed to do that. To fix this, we use the chain rule. Now the chain rule states basically if I'm looking to change dv dt, what I do is I change it into two new derivatives. The v goes on the top, the t goes on the bottom. So in effect I'm splitting the v and the t apart. What letter I choose to go underneath is the letter I need to differentiate with. It's going to be dx. So it's going to be dv dx by dx dt. But what we know about dx dt is v. So this means that dv dt is phi times dv dx, because this here is v. Okay, so we're now going to get v dv dx equals 2x, oh sorry, it is 2x, isn't it? 2x into x squared. Now I'm just going to multiply that out. Don't see the point in having them separate, so I'll just go 18x plus 9x squared. Next step, bring up the cubed. 2x cubed, sorry. Now 2x cubed. Now, what we get next is we cross multiply up the dx. V to v equals 18x plus 2x cubed. And then there's a dx at the end. I'm just going to rub out the stuff to the right here. Now that we have that done, what we're going to do is we're going to integrate both sides, but we need to find some limits. Okay, so we go back up to the top, and we know that dx dt, or v, is 9 when x is 0. So v is 9 when x is 0. So v is 9, x is 0, top letter is v, top letter is x. Let's integrate both sides. Integrate v, we're going to get a half v squared. Because a half v squared, when you differentiate it, turns into v. V over 9 equals, integrate 18x. We're going to get x squared. What number goes in front of x squared, so that when you differentiate it, it's going to be 9. Okay. Next one is x4. Add 1 onto the power. When you differentiate this, you get 4x cubed. We want 2x cubed. Therefore, we need to halve the coefficient. And that is from x to 0. Let's multiply these out. We're going to get a half v squared minus a half 9 squared equals 9x squared plus a half x to the power 4. Now, what we might want to do with the two of these is we might actually want to multiply out both sides by 2. So what we're going to get is v squared minus 81 equals 18x squared. 18x squared.
Oh, yeah.
Definitely 18x squared plus x4. Bring it over the other side. V squared equals x4 plus 18x squared plus 81. Now, here, what I could say is, I know this is a type of a perfect square, but if you don't see it, what you could say is let y be equal to x squared. Therefore, y squared is x squared 2b squared, which is x4. Now, I'm using this y value just to show you how to factorize this. V squared is therefore equal to y squared plus 18y plus 81. V squared is therefore equal to y plus 9, y plus 9. But we all know it's not y, it's going to be x squared. So we just change it back into x squared then. Just in case you didn't see the factorizing, this is a teaching method. Okay? It's the same thing as factorizing y squared plus 18y plus 81. Okay? Now that that's done, we now know that v squared is x squared plus 9. What we have to do is we're going to square root both sides like we did last time. Square root them. And what we'll get is, Garrett says there's 4 possible combinations here, plus and minus on both sides. But realistically, it's 2 combinations of 2, so you just ignore the left hand side and put plus or minus the right hand side. Now, which one's right and which one's wrong? To check out which one works, we need to go back up to our limits. Now, we also got to remember is that this is v and x. V is 9 when x is 0. V equals 9 when x is 0. Lads, it was the square root of x squared plus 9 to be squared. That's why the square root gets rid of the squared sign, and we're left with plus or minus x squared plus 9. Now, put in v equals 9, put in x equals 0. Okay? We can see that the minus version won't work, because if it's minus, v would be minus 9. So check your limits. We're automatically ruling out the minus version now. The minus version is not an acceptable answer. Now that we have that done, what we're going to do next is we're going to convert v back into dx dt. Next step, we're going to cross multiply, bring the t up, bring the x squared plus 9 down. We're going to get 1 over x squared plus 9 dx equals dt. Integrate. X on top for this one, t on top for this one. Recheck your limits. My limits are x equals 3 when t equals 0. T is 0, x is 3. Look this up in your notes. In your notes it will say 1 over x squared plus a squared is 1 over a tan inverse x over a. So what we can say about this one is the 9 changes into a 3 squared, therefore a is 3 and x is x. 1 over 3 tan inverse x over 3 from x to 3, and just going to rub that out, that's in your tables. Okay, and then the other side is integrating 1 to t, which ends up to be t from t to 0. Next step after that, put into both of them a third tan inverse x over 3. Oh sorry, x over 3 is right. A third tan inverse 3 over 3. And 3 over 3 is 1, so we can just put a 1 in there instead. Equals t minus 0. Now, what we're going to be left here is we got to isolate. Just give me 1 second to reread. I want x in terms of t. That's the whole goal of the question. The top letter in terms of the bottom letter. So I need to get x on its own. So we'll figure out this now. I'm going to multiply both lines by 3. Okay, so I'm going to get tan inverse x over 3. Tan inverse 1 is 45 degrees, yeah, which is pi over 4. And the other side would be 3t. Bring the pi over 4 over the other side. Tan inverse x over 3 is 3t plus pi over 4. Next step, bring tan inverse over the other side. X over 3 equals tan bracket 3t plus pi over 4. Next step after that, bring up to 3. X equals 3. X equals 3 tan 3t plus pi over 4. Okay, number 7. Okay. The whole point of this question is to get y in terms of x. How do I know that? It's d2y dx squared. That means get y in terms of x at the very end of this question. Step 1, move the 2 and y cubed over the other side. So we're going to get d2y dx squared. And that's going to equal minus 2 over y cubed. Let d2y dx squared is the same thing as the ddx of dy dx. We're going to let v be equal to dy dx. So therefore d2y dx squared is dv dx. Now the problem with this is when we change d2y dx squared to dv dx, once again we want to differentiate or integrate with respect to x, and there's y's over the other side. This is a problem. We once again go to the chain rule, and the chain rule is going to be, you write down what you have, dv dx, you separate out the dv to the front, the dx to the back and the bottom, put in whatever letter you need. You need y's, dy and dy. Next step is to replace dy dx is v, so replace v with dy dx. So this here is actually v, so it's going to be v dv dy. Now, v dv dy equals minus 2 over y cubed. Cross multiply, v dv ends up to be minus 2 over y cubed dy. Go up to the top, look for your limits. The limits are when v is now dy dx, when v is root 2, y is 1. So y is 1 when v is root 2. Y is 1 when v is root 2. So root 2, 1 on the bottom, y on the top because it's y's, v on the top because it's v's. Integrate. A half v squared from v to root 2 equals, this one here is a bit more difficult, so I'm going to change into minus 2 y minus 3. And it's going to be y minus 2. Integrate y minus 2. We actually get minus 2 y minus 3. So it's actually easier than I thought. Okay. That is the same thing as 1 over. We don't have to rewrite the full line. We can just put it underneath. But you don't want to do more work than you have to. It's the same thing as 1 over y squared. Next part. Integrate and put in your limits. So you get a half v squared minus a half root 2 squared. Next one is going to be 1 over y squared and minus 1. Okay. Now what happens on both sides is, as Garrett might have said there, root 2 squared is 2. a half of 2 is minus 1. These two cancel off with each other. So what we're going to get is a half v squared equals 2 over y squared. Now what we got to do here is get v on its own. Oh sorry, 1 over y squared, excuse me. I'm actually a step ahead of myself as well, sorry, I was thinking the next step up. V squared equals 2 over y squared. Square root it, and please remember your plus and minus values. Plus or minus the square root of 2 over y. Once again, y squared. Okay, we got to check our limits. Our limits are when y equals 1, phi equals root 2. When y equals 1, phi equals root 2. This is from the top of the question. Okay? Therefore, phi is root 2 when y is 1. Therefore, it's root 2 divided by 1. It's correct. However, the minus value is not correct, because the minus value will give you minus root 2. So you now know once again the minus value will disappear, but you should really check. Okay? It might not always be the minus one. So there could be the case where actually the one time it works will be in your leaving cert. Okay? Now.
So can you scroll a bit?
Yeah. Okay, happy?
Yeah.
Okay. Next one. We now know that we let v be what? What did we say v was? V was dy dx. So dy dx, this is phase 2 of it. We've just completed phase 1. Phase 2 is root 2 over y squared. Okay. Now, so okay, so we can change that into root 2 over y, because it's the same thing as root 2 over root y squared, and root y squared is y. So we just free up the y now, okay? So we're going to get root 2 divided by y. Cross multiply y to y equals root 2 dx. Integrate. Okay? And when we're integrating, what we should get is when y is 1, x is root 18. 1 and root 18, y and x integrate. It's going to be a half y squared equals root 2x, and this is from x to root 18, and this is from y to 1.
Root 2. It says x is root 2 and y
If we go back to the top, oh sorry, find the value of y when x is root 18. So you are right, it's root 2 and y equals 1, excuse me. Root 18 is the question after we get the general solution. Good spot, Carl. Okay, is root 2. So what happens here is we get root 2. Instead, integrate both sides, and we get a half y squared minus a half times 1 squared equals root 2x minus root 2 by root 2, which you all know is 2. So we're going to get a half y squared minus a half equals root 2x minus 2. Let's multiply everything by, bring this over, and then multiply everything by 2. It's going to be minus 1.5. Minus 1.5 multiplied by 2 is minus 3. Multiply the y squared by 2, you get y squared. Multiply root 2 by 2, you're going to get 2 root 2. 2 root 2x minus 3. Okay. Now, therefore, y, the general solution is going to be y equals the square root of 2 root 2 x minus 3. Now, the whole point of the question is to find the y value when x equals root 18. So what we can do here is it's going to be 2 root 18. Oh, sorry, 2 root 2. So y equals 2 root 2 root 18 minus 3. That's going to be 2 root 36. And 2 root 36 is 2 times 6, which is 12 minus 3. Root 9, y equals 3. Not plus or minus 3, in fact. Okay.